Hello, everyone. I am Hoon KIM, professor at Bugyong National University in Korea. Today, I'm so glad to present about fisheries situations and management systems in Korea. I hope that this lecture will be useful for your understanding on your fisheries management in the future. I will introduce myself briefly. Again, my name is Hoon KIM, and I am teaching and researching at the Bugyong National University. My university was a fisheries university, the only one national university for fisheries in Korea. But it has changed the name, become the much bigger university since 2006. My research area are fisheries economics and policy, aquaculture economics, bioeconomics, especially specialized in fish stock assessment and policy analysis, and international fisheries management and policy. I am also acting international expert in fisheries and aquaculture in various international organizations like OECD, FAO, PICES, and the United Nations, and so on. Today, I will talk about fisheries and aquaculture situations in Korea, including distribution and processing situations. Especially, I will also talk about new trend in fisheries management, named as a market or consumer-based fisheries management. Its importance is growing fast nowadays, and I believe you have to understand its concept, objectives clearly for development of sustainable fisheries. First, let me talk about fisheries situations and management in Korea. The fish stock biomass has been estimated to decrease over time, and the catch amount was a peak in 1986, but it has been decreasing since 1990. It was a peak at 1.7 million tons in 1986, but it is only 0.9 million tons as of 2019, last year. That is, the catch amount has been decreased by almost 50% so far. This is not a problem only for Korea. It is general situations in the world, as you may know already. The issue is to find out the reasons why the fish stock biomass is decreasing and how to rebuild and recover the fish stocks. That is our main concern and interesting point. You can see the trend of fish stock biomass by estimating CPUE, that is a catch per unit effort. As you see this graph, the engine power is decreasing over time, which means, and we can guess the fish stock are declining over time. In the most countries, the government control the size and the tonnage of vessels, but they do not control engine power. Therefore, as the fish stock decrease, the fishermen increase the engine power, which has a negative impact on fish stock again, and it decreases more. This is called vicious cycle in fisheries. And we have to cut and stop that circle for sustainable development of fisheries. Regarding the reasons why fish stock biomass has been decreased, we can say the some reasons as follows. The first, destruction of habitats by contamination of marine environment and climate change and ecological change in fish species. As you know, the mortality of fish species relies on both nature and fishing activities. The first cause is related to the increase of natural mortality, which was caused by human activities. Second, the gap between a fishing ground and the national jurisdiction. If a fish species migrates between Korea and other countries such as China and Japan, the resource management cannot be done by Korea itself. Lastly, multi-species, multi-fisheries situations of Korean fisheries. A certain single management measure may affect different species or fisheries together. This may have negative impacts on the compliance of fishermen with the management measures. In order to overcome this situation, integrated fish stock enhancement program is necessary. Integrated fish stock enhancement program is aimed to increase fish stocks by improving marine environment, restoring productivity of the natural population of fish. The program should take a role to play in fisheries management as a part of integrating fisheries management strategies. The program is consisted of 4 detailed programs in Korea. The first one is the artificial reef program, which creates habitats and spawning grounds. It has been implemented since 1971, and 200,000 hectares of artificial reef were installed by 2017. Another is the Marine Seaweed Forest Program, which is aimed to recover ecosystems of fishing grounds. Marine seaweed forests provide the natural habitats for fish and shellfish to spawn, breed, and feed. $281 million will be spent on this program for next 10 years, and 35,000 hectares of seaweed forest will be created in Korea. The third one is the FRY, Juvenile Fish Releasing Program, which enhances the recruitment of fishery resources. It also has been operated since 1976, and 400 million fish fries were released between 2004 and 2017. The last one is a sea ranching program. It is constructed for sustainable fish stock reproduction by installing artificial reefs and releasing juvenile fish densely. The program has been operated since 1998, and the 5 large-scale sea ranches and 20 small-scale sea ranches were constructed by 2010. Sea ranches are beneficial not only for sustainable fish production, but also for tourism. Recently, the Korean government implemented the ecosystem-based fish stock rebuilding plan. The ecosystem-based fish stock rebuilding plan came out for several reasons, such as limitations with the conventional management system and the necessity for easy fish stock management. The government realized that it is necessary to recover the individual species for management of all fish species. So, a fish stock rebuilding plan has been established in 2002 and 2005. It is still establishing nowadays. The concept of ecosystem-based fish stock rebuilding plan is to increase the fish stock to the target level within the target period with effective fisheries management measures and the stock enhancement program as well. Various players take charge of the ecosystem-based fish stock rebuilding plan. The MOP, Ministry of Oceans and Fisheries, select target species based on the stock assessment report. Also, the MOP requests a Fisheries Management Council for establishment of a fish stock rebuilding plan, and it's administrate a fish stock rebuilding plan. NFRDI is the National Fisheries Research and Development Institute. Now it changed their name into a National Institute of Fisheries Science now, reports stock assessment outcomes, select and submit recommendations. Federal and the local scientific council review, analyze, establish recommendations. Fish stock enhancement centers support scientific council and submit their recommendations. Local Fishery Resource Management Council, which is composed of local government, fisheries cooperatives, fishermen, experts operate a fish stock rebuilding plan based on recommendations and monitoring. Also, it gathers a fisherman's opinion and develop effective management measures. This is the process of a fish stock rebuilding plan operations in Korea. After the stock rebuilding plan by species is set initially, the stock assessment on the species is done by National Institute of Fisheries Science or local government. With the outcomes of stock assessment, central or local scientific council make a recommendation. According to those in the recommendation, central or local fishery resource management council establish stock rebuilding plan. After that, MOP, Ministry of Oceans and Fisheries or local government, finally approve the fish stock rebuilding plan. For the implementation of fish stock rebuilding plan, various organizations such as National Institute of Fisheries Science, Coast Guard, local government, and fishermen plays their part. During this implementation, scientific council and the local government monitor the resource status and make another effective recommendation if necessary. With the recommendation, the Central or Local Fishery Resource Management Council and the Scientific Council review and evaluate the annual fish stock rebuilding plan. According to the review and the evaluation, Central or Local Fishery Resource Management Council revised the fish stock rebuilding plan. There are four very distinctive situations on the Korean ecosystem-based fisheries resource rebuilding plan. First one is that it emphasizes the management of individual species with the conventional multi-species fisheries management and the stock enhancement program. Second, by using direct measures and the stock enhancement program together, effective recovery of fish stock is possible while maintaining fishing activities. Third, connecting with a community-based fisheries management, which promote a voluntary participation and effectiveness of fish stock rebuilding plan could be maximized. The last one is a rapid increase of community participation in this fisheries management. A new self-management system allows fishermen to regulate themselves with their own responsibilities. They make a decision on the management and the use of fisheries resources themselves. Also, they should take responsibility on their decision. The government assigned a public fishing village guidance serviceman to help fishermen technically. Moreover, private consultancy service is given for community with poor progress or newly participated community to provide one-to-one customized education. Communities which adopted this new self-management system rapidly increased from 63 communities on 2001 to almost 450 communities on 2006. It is still increasing nowadays. However, the current fish stock rebuilding plan has also some limitations. As you see this picture, the significant part of Korean EEZ is overlapped with the Japanese one and Chinese one. That makes operations of fish stock rebuilding plan only by Korea cannot obtain complete effectiveness in fish stock recovery. So, joint fisheries management system among Korea, China, and Japan must be established for cooperation on large marine ecosystem-based fish stock rebuilding plan. Now, let's talk about the aquaculture situation and the management in Korea. Korea is surrounded by waters on three sides, and the situations of each sea is very different. Let's talk about details of East Sea, Yellow Sea, and the South Sea preceding slides. The main characteristics of East Sea is that the coastline of East Sea is very simple and deep. Due to that situations, there are insufficient live food organisms for fish. So inhabited fish species are not dwelling, but migrating to feed themselves. Also, there is a stronger wave on the East Sea. Because of the two situations I mentioned before, there is only a few aquaculture species on the East Sea. The main characteristics of the Yellow Sea is that the wide tidal mudflats and the high tidal range. Thanks to the wide tidal mudflats, the self-purification ability over water pollution is very strong. Also, in the mudflat are good environments for shellfish and mollusks and any other animals. However, the water temperature of Yellow Sea is relatively low in winter and it's too high in summer. That is a critical factor for aquaculture, especially for fish aquaculture. Main characteristics of South Sea is that the complicated sea lines consisted with many islands and bays. Thanks to this and the characteristics, South Sea offers good sites for net cage aquaculture. Also, the water temperature is friendly for aquaculture of warm water fish species. With the warm water temperature, almost warm water fish can be overwintered. This picture shows the main aquaculture species by coast. As I mentioned, there are many different various aquaculture species on the south coast thanks to good environmental circumstances. This slide shows the development progress of aquaculture in Korea. Marine aquaculture has rapidly developed since over the last 30 years in Korea. The major species have changed every 10-year terms. Seaweed aquaculture was the main species of marine aquaculture from 1960s to the middle of the 1970s. So, as shellfish farming from middle 1970s to middle of 1980s. Meantime, breeding and hatching technologies have been established from some marine fish such as the red sea bream, olive flounder, and the black rockfish from 1980s to the 1990s. Since then, the marine fish farming has become the most rapidly grown industry in Korea. From 1960 to 1970s, it was very in the first stage of shellfish and the seaweed aquaculture. The mass aquaculture technology, what is called the hanging culture for seaweed such as sea mustard, was developed. Also, the hanging aquaculture method for oyster was developed. In the 1980s, fish and the crustaceans aquaculture became mainstream thanks to success of mass artificial seedling production in different kinds of finfish, shellfish, and crustaceans, especially olive flounder as a fish. In 1990s, genetic technology was introduced for aquaculture in Korea. This made all-female production possible, which improved the profitability of aquaculture industry. Also, the aquaculture species were diversified. Various species such as red sea bream, black rockfish, tiger pooper, olive flounder, abalones, and so on were cultivated. In 2000s, competitiveness and the fundamental technology of aquaculture were strengthened. Especially four principal technology development projects such as selective breeding, formulated feed, vaccine, and automation were carried out. Moreover, offshore aquaculture, which can mitigate the problems of conventional inshore aquaculture, was tested and demonstrated. Here are some of the characteristics of Korean aquaculture. The first, aquaculture in Korea is traditionally a family-oriented and small-scale business. This made the production cost relatively high. The second, the license system on aquaculture activities very and complicated. The aquaculture license is regarded as a real estate. Third, there are various aquaculture species and aquaculture ground due to different situations among different coasts. The fourth, people in Korea love to eat fisheries products. Per capita, food fish supply in Korea is 38.5 kilogram, while that of world is 13.4 kilogram. Also, there are various fisheries dishes such as raw fish, soup, grilled, boiled, dried, and so on. Fifth, Korea has a highly developed aquaculture technology such as seed production, ongoing technology, culture facilities, and so on. Lastly, Korean government supports the aquaculture business activities. For example, it runs many research institutes, educational institutions. Here is the production of volume of capture fisheries and aquaculture. The volume of capture was 6 times bigger than that of aquaculture in 1970s. However, the volume of aquaculture is bigger than that of capture fisheries in 2016. Also, you can notice that aquaculture in Korea rely on the marine aquaculture mostly. This table shows the production volume of aquaculture by category. Thanks to the development on the aquaculture technology, the production volume of shellfish jumped in 1980s and that of finfish in 2010. However, seaweed aquaculture still occupies more than 75% out of total marine aquaculture production. Thanks to development on aquaculture technology, the production volume of the shellfish increased in 1980 and that of the finfish in 2010. However, the seaweed aquaculture still occupies more than 75 out of total marine aquaculture production. However, the proportion of each category changed in terms of production value in 2017. The production value of fish occupied 34.2% out of total aquaculture production value. Also, the portion of seaweed production value was just 29%, even though their portion of production volume was 75%. This implies that the fish aquaculture play a critical role in increasing values to the aquaculture industry. Let's take a closer look at marine fish aquaculture production. In terms of production volume, olive flounder accounts for almost 50% of fish aquaculture. Also, production volume of black rockfish occupies more than 1/4 of total aquaculture production value. The production volume of other species such as mullet, sea bream, right-eye flounder, sea bass shells 1/5 of total. Olive flounder took up more than 80% of total aquaculture in terms of production volume in 1995, while rockfish occupied just 12%. However, after 2000, portion of olive flounder in terms of production volume stayed around 50 out of total. Also, that of rockfish stayed between 25% and 30%. After 2005, production volume of olive flounder, rockfish, and other species are almost steady. And with the pie chart on the right upper side, you can note that olive flounder shares 2/4, rockfish shares 1/4, and the other species share 1/4 out of total in terms of production volume. These are aquaculture facilities. The first aquaculture on upper left side shows a net cage aquaculture facility. And the picture on upper right side show embankment aquaculture facility. Two pictures on the lower side show inland-based aquaculture facilities. Let's take a closer look on a shellfish aquaculture production. In terms of production volume, total production volume of aquaculture shellfish increased on 1980. Pacific oyster accounts for most of shellfish production volume. In addition, other species such as abalone, Japanese carpet shell, inflated arc, scallop, blood cockle have been farmed. These charts show that oyster aquaculture took up almost 3/4 of total in 2017. Because the Korean people like oyster very much, there are lots of oyster farms in Korea. Those farms produce mass amount of the oyster. It is followed by mussel, abalone, and Japanese carpet shell in order of their production volume. There are several types of oyster aquaculture method. The major one is a hanging culture, which you can see on the biggest picture on this slide. Three methods on right side are applicable on mud flats. The difference among three methods is the way how humans provide attachment substrate for oyster. Sting method uses sticks, a bottom culture method uses stones, the tire method uses tires as attachment substrate, but this method is not used anymore nowadays. Also, there is another method which is called packing stirring method, which is also applicable on mud flats. The picture on the upper right side shows abalone. The picture on the lower right side is a net cage aquaculture facility for abalones. The shelters, which is shown in the picture on the left lower side, are set in the net cage in the ocean. This table shows the productivity volume of aquaculture crustaceans. The major aquaculture crustacean species in Korea was flesh shrimp. Its production volume was more than 1,000 tons in 2000. However, flesh shrimp aquaculture had been vanished because critical viral disease outbreak in the middle of 2000s. Instead, white leg shrimp, which is strong against the viral disease because a major aquaculture crustacean species. In 2017, the production volume of aquaculture shrimp is 5,000 tons. Meanwhile, kuruma prawn had been aquaculture in 1970s to 1990s before the outbreak of viral disease. Yes, I will finish the first part of my lecture today. Thank you.